All right. Hi, everyone. I'm Julien Salvi, French engineer, French Android engineer, and I'm super excited to be here. And today I'm going to talk about augmented reality on Android. As I say, I'm Julien Salvi. I'm an Android engineer at Innovator, French startup. I've been around Android since Froyo, almost 10 years now. I'm part of the Paris Android user group. And beside the Android stuff, I listen a lot of punk music and drinking a lot of IPA beers. And you can find me in Twitter at Julien Salvi. So today I'm going to talk about augmented reality on mobile first, have a bit of overview of what's going on the Android ecosystem. And then I'll dig into ARCore and Sceneform and see how you can build a ship with the basic feature of ARCore and Sceneform. And then I'll talk a bit about the nice feature ARCore has, and it's really interesting stuff here. So first, augmented reality on Android. I'll start with a big number. So almost a billion users can access to augmented reality in the world. It's a big number, so the AR market is quite large. Augmented reality is on mobile for quite a long time now, but with the recent progress, we can reach a lot of devices as they are more and more powerful. So it's a pretty big market for now and the future. So why building AR apps? So for example, for housing or real estate, so you can place your chair, your sofa on your in your apartment, for example, or for visiting a new places you want to buy. Also for gaming and leisure, as you can see, the well-known Pokemon Go was quite a thing for AR. For science, education, or industry, for learning new things, have a demo, or for science, for example, have a skeleton live in your room. Or a new way to enjoy sports, like having a lot of statistics about a game you are going to watch or you're watching. It's pretty amazing what you can get with data in AR combined for sports. Or, for example, just enhance your daily life. If you are using maps, you can get like some AR indications of where you're gonna go, so which direction, and see some pretty nice marker in AR. And of course, you can just build AR apps just for fun. It's the main thing here. So augmented reality on Android, you can go for ARCore, built by Google. For now, it's like the recommended things if you want to build AR application with the Google systems. You can go for Viforia, it's another SDK, or you can go for Wikidid AR, or if you like to go for an open source platform, you can go for AR Toolkit. And of course, if you want like a big going further, you can go with Unity and maybe use it with ARCore or AR Foundation for building cross-platform application. So about ARCore and Sceneform, ARCore is a nice SDK built by Google in 2017, and Sceneform is built on top of ARCore, came a year later. There are a lot of features that ARCore brings, like motion tracking and the environmental understanding or light estimation. It's like the light of the room will be understood by the ARCore application. And the nice thing Sceneform is bringing is like you can use Android UI in AR. So you can build your layouts as you are building it for the your Android applications and bring into AR. And more than 250 Android devices are now supported by ARCore. So you have a pretty big target here to build ARCore apps for a large market. So let's dig into ARCore and Sceneform. That's what we want here, and let's see how we're gonna build our ship. So in this part, we're gonna learn the basics of ARCore and Sceneform. You'll learn how to display some basic shape like a cube, a cylinder, or a sphere. And you'll learn also how to display complex 3D assets. We'll learn how to use Android UI components in our AR app and how they can interact with your assets. And also, we'll add some pretty nice animations and see how we can use some of the Android animations with our 3D assets. So first steps, we're gonna learn how to use the basic shapes. So it's kind of like a sheep in a box here. Then we are building like more complex and more realistic sheep with the basics form. And then we're gonna have the like more and more realistic sheep with a complex 3D assets. First, if you want to build for ARCore, if it's an AR only application, you have to target SDK 24. And if it's optional, if it's just a small part of your application, you can target 14 as a minimum or above if you want. OpenGL3 is required for our application and Sceneforms, and your device must have the Google Play services for AR. Even for the Huawei phones or the phones that don't have the Play services, you can still install this application, and Huawei phones will support ARCore applications and ARCore features. And if you are using Sceneform, you must target Java 8. So these are the requirements for building for AR and Sceneforms. So in your manifest, you have to access to the camera. So OpenGL3 is required. If you are building an ARCore only application, you must set the requirement for ARCore. So adding the dependencies into your Gradle. So we bring by the Google repository, and you have to set the ARCore dependencies in the 120, the latest. And for Sceneform, the 117.1. But a couple months ago, maybe a bit more, Sceneform is now open source. So the 1.16 is not available as the Maven dependencies, you can fork it from the GitHub repository and then add it to your project as a module. So as Sceneform is now open source, if you want to go for a new project, go for the 1.16 and fork it and implement so whatever you want if some features are not available. So as I said, Sceneform 1.16 came open source. I think it was in March. Before that, we use ACFI SFB assets. It's a proprietary 3D format. So as Sceneform is now open source, it's deprecated. It cannot be used by the open source version. Now we can use, and you have to go for the GLTF assets, which is like has better performances, and it's much will have a lot of better performance in your application. So you can go for the 1.16 if it's a new app, but if you have already your application with Sceneform, the 1.15 or 1.17.1, you can still stick with these versions. So let's see a bit of code. So how to build the boxes. So first, you have to add your AR fragment in your activity or in your fragment. So the AR fragment will do all the work for rendering the camera, and it will be the playground for your scene. But it's pretty simple. So in your activity, you just like check if the device is supported or not. If it's not, you can skip the error path. But anyway, you can just find your fragment and then play with it. So here you can get your fragment in your activity. But first, before going into more code about adding a cube in your scene, I just want to talk a bit about 3D math. Not so complicated here, but as you're going to build some AR application in like an augmented version of the real reality, so you have to know a bit of 3D math. So as we are in the 3D world, we are using 3D vectors for position, translation, and scaling. And we're using a very nice mathematical concept called the quaternions here. We are using it for rotations. So quaternions, I'm not going like to dig on these math things. So it's pretty much a 4-component vector, which is very efficient for calculation, for doing some rotation in a 3D world. And like OpenGL convention, we are using the right-handed system for coordinates. So here the right hand with here the middle finger is the Z axis with the X, Y, and Z. So for the basic shapes, you can load some color. For example, you can make it red, blue, or whatever color you want to. You can also use some transparency for color and texture. And for texture, you can load your PNG texture to build your shape. So it uses a material factory to generate these things, and it's pretty simple with Sceneform. So for the shape factory, we have 3 different shapes. You have a cube, a sphere, and a cylinder. So every shape accepts the material, so you can like add a color, a texture, or transparent color. And for placing the object inside the scene, you must provide for a center, a radius, or a size of the shape. It depends on what you are building. So, for example, here we are going to create a colored cube. So we just create the material for like a red color. And then the material will be injected in the shape factory to make the cube with here the center and the side of the cube. And then we'll have our renderable available, and it will be available for our scene, and we're gonna see how we can inject this renderable in our 3D scene. So here the same thing, but for like a transparent color, just like a different method, same complexity. And same thing for loading like a texture. So maybe available in your doable folder. So we are downloading the bitmap and then injecting in the shape factory. And so you have now your renderable, and you want to place this cube inside your AR scene. So we can add a set on tap listener in your fragment. So a tap will add a new shape renderable in your AR scene. So we increase the anchor, the main anchor of your scene, describe the fixed location and orientation in the real world, and then we can add our box inside the scene attached to the original anchor, the main anchor. And that's it. Like, you just bring some free chips in boxes in your AR scene. But we can do more, and we can build a more realistic ship. So let's do this and see how we can do it. So in this part, we're gonna learn how to build a more realistic ship with the basic shapes of Sceneforms. So we're gonna use cylinder and spheres, and we can use also a wool texture for the body of the ship. We learn how to use compose nodes in order to display our ship and place components. And also we're gonna learn how to display Android UI in AR, and like end up with a nice animation in the end. So this is a pretty big thing you have to know when you are building some AR application with Sceneform. When you place something on your AR scene, everything is a graph. So at first you have your main anchor, and then you attach a node, and a node represents a transformation within the scene hierarchy. And a node can only have one parent and can have 0 to n children. Each node is a renderable. So we have to compose with several nodes to build our more realistic ship. And here how we're gonna build our ship. So it's a combination of sphere and cylinder. So our main ship has a head with 2 ears, which all of this is 3 sphere, 1 for the head and 2 for the ears. They are the main body part, so composed of 4 different sphere to make it like a bit fluffy for the wool part, and then 4 cylinder for each leg. So let's now build our ship. So here is a simple code of how we can add the free leg in our scene. So this is our main ship. We have the ship parent here. And then we are going to build our our 4 legs. So we're going to place them in the scene. So to like to a rectangle for like regular ship leg for ships. Then we're gonna attach all the renderable to the chip node. And after assembling and positioning all of the assets in the IR scene, we are ended up with like a more realistic ship built with ARCore. And you can place it everywhere, and you can even take selfies with him. It's just fun and stupid, so do it. But we can do more. We can do more with bringing some Android UI to IR. So you can build, you can add like a card which describes the ship. So you can build the layouts as you are building your usual Android application. So you end up with your XML layouts. You can add the constraint layout, frame layout as you want. It will be rendered in an AR as it will be rendered in an Android application. And also, all view interactions are working as usual, so you can add your on-click listener, your swipe, your, for example, selecting text or something like that. That's a pretty good things where you can interact and build some complex UI UX stuff as you are building your classic Android app. So here is how you can render an XML layout in AR. So the first line of code is like how you can like place your card in the scene, but beyond the view renderable is what we need here. So you have to just inject the layout, the chip card layout. Then it will be built. It will be transformed to a renderable. So the renderable will be attached to our chip card, and then we can bind the views, access the views of the renderable to like inject some data, display our images, setting the clicks list, setting the listener, and so on. And then you can also attach an animator. We'll see next. And that's it. We can like display some nice Android UI inside our scene and attached to our ship. So I was talking about animation. So for this sample, I decided like to implement a nice embedding animation. So it's a component of a bit of rotation and translation of the head. So if you're familiar with animation of Android, you can use the object animator class from Android to animate nodes. And you can compose animation thanks to the animation sets. So you can play with your 3D assets and add some animation about the position, the scaling, and the rotation all at the same time. So here is how we can create an embedding animation. So this is the components of our animation. So a rotation here. So we are using the location rotation, the local rotation, and then the local position for the translation. So it's pretty much similar to the object animator you can use in your regular Android app. And then you can combine these two animation within an animation set. And so set the rotation and the translation and play it together at the same time in order to have a very nice and smooth animation. So it's nice to see some slide, but seeing a live demo is like much more visual and much more cooler. So let's see how it looks like in the real world. So, ta-da! So here's the simple application I made. For example, here we are gonna scan the ground. And here we can, for example, add a cube. We can scale it, move it around. We can add another cube with a texture. We can rotate it. And finally, like a transparent cube here. So this is basically playing with cube texture and colors. But what we want here is see how our ship looks like. So I'm gonna scan the ground again. So here is our ship, Marvin. So when I click on the node, I can display the card. So here is Marvin the chip. So here with our Android UI, I can trigger the headbanging animation by just clicking on the checkbox. And then the chip will be animated with our compose animation. So the headbanging animation and the like walking kind of animation. All right, so and to see a bit of code. So here is our Android Studio project. So to build, for example, our ship asset, so there is a bunch of ship here. So here is how you can create a ship. So it's a composition of legs. You can build a body part, then set it together. And here's how you can create all the sphere and the cylinder that will compose your ship. And yeah, just the compose animation here. What's on the fragment here, just like inject like a bit of light estimation to be more realistic and more realistic in our environment, and then just a tap listener to place our sheet. So if we're gonna go further, we're gonna use some complex 3D assets because we cannot do everything with just cylinder, sphere, or cubes. So if you want to go for complex assets, just use GLTF format. For me, is one of the best formats now for 3D assets. Before Sceneform, you could use Object or FBX formats. But for now, as the Android plugins for transforming of FBX format is broken, so Sceneform is now open source. So go for the GLTF assets. And where you can find some very nice assets if you don't want to build them. So you can use go search and find some very nice stuff on Sketchfab or on Poly by Google. You can use also TurboSquid or the Unity Asset Store, but I really recommend to go in Sketchfab. You can find some for free or just like awesome assets and complex stuff for just a couple bucks or $10 at most. And if you want to be sure that your GLTF or GLB asset is good for ARCore, Google provide a website to validate the format and your 3D object. So it's very nice to go for that before implementing your asset in your ARCore application. And this is like the preview we used to have before Android Studio 3.6. So it was the Sceneform plugin when you can like have a preview of your SFA format. So for loading, for example, you can load a GLTF asset which is online. It's supported, so you can load it remotely or locally. It's pretty simple, like the loading of the cube or a cylinder. It's pretty much the same complexity. And then you have your object animator. Can still be used on the 3D object, but you can also use the GLTF animation provided by the 3D assets. And all of this is available by the great work of the team at Google that made the filament. It's a very powerful library to render and load 3D assets. It's a great physics engine. And so for playing 3D animation that are available in our assets, so it's pretty simple, just few lines of code to retrieve the animation and then start the animation whenever you want. So congratulations, you are all set for building awesome animation, awesome ARCore and Sceneform application. So just enjoy and do some crazy things with it. And I go further with some ARCore features which are very nice, because ARCore also provide augmented images, augmented faces feature, cloud anchors, and a bit more. So let's talk a bit about augmented images. So it's a feature where you can bring image to life. So your image in the real world will be a marker, and the ARCore stuff will understand that this is a marker and will add like a 3D animation or 3D asset or 3D stuff to the real world and see how this marker can be like moving all around. So ARCore can store up to 1,000 images reference per database, so you can have a lot of markers, bring a lot of images to life. And then there's also the augmented faces feature. So this is here. It's only like to build some filter like Snapchat, Instagram, or Messenger. So your face is mapped at a 3D mesh. So you can place then the assets you have drawn in your, for example, in your nose, in your mouth, or in your forehead if you want have some ears. Like it's just nice and it's stupid. It's good to do it. It's a nice play if you want to have fun with some filters. Not very serious thing here. But the best thing for me is the cloud anchors. It's here ready to build some multi-user IR experience. So the data of a 3D asset will be shared thanks to, for example, thanks to Firebase, and the data will be shared with all the users that are at the application. So, for example, you can play some very nice ping pong game in AR. So you are scanning the table, and the ball will be shared between all the players in the room. And recently, they announced also the permanent cloud anchor just a few days ago. So it's very cool because you can put some air marker all around the world, and they can be here for months, for years. You can like go and chase your own marker or something like that. Yeah, it's pretty cool. They also introduced in ARCore the Depth API. It's very here to have more realism in your scene. So the room will be mapped almost exactly as it is in the reality. So if you have a box in your room, and if you place an asset beyond this box, the 3D asset won't be rendered as it's hidden by this box. So it's all about controlling the object occlusion. And also one more nice thing to be more realistic is the lighting estimation. Here we can use, for example, environmental HDR or ambient intensity. It's enable like more immersive and realistic experience because it uses the lighting of your real scene, the lighting of the sun, the reflection of on the different material. It will be like more and more realistic for building air apps. If you want to know more about the stuff of ARCore or Sceneform, there is a lot of nice code labs in the Google Developer Code Labs. You have also now some documentation. If you want to go for some design concepts, you can go for this link, and you can find the source of the Sheep AR fun sample on my GitHub. And thank you everyone for attending my conference, my talk about ARCore and Sceneform. Hope you will have fun building some nice AR application. And if you have any question, feel free to reach me now or in the social media. So the question: you have any concerns around using Sceneform? Now it's been a bit mothballed by Google. Super soon, but since that official GitHub repository is marked ARKit and automated, is it being maintained by anyone else in a fork? Good question. I was about like a couple days ago to fork my own version of Sceneform to implement the depth API because it's not available yet. I think if you're gonna go for Sceneform now, you are on your own. You have to build your stuff on your own. It's pretty solid base, but I don't know if Google will like manage to do some bug fixes in the future. I don't know. Is there an emulator that you can try AR feature? Good question. I've always working with real devices, so I didn't give it a try. But maybe if you have the Play services for AR, it can be possible. I don't know. I'll try it. The code for your demo is public, is posted somewhere. Can we access it and use it? Yes, of course. It's available on my GitHub. So the link is on the slide. I will post it later. So yeah, no problem. Can you create centric circle around? What? Nope. The code for you. So don't thank you. Oh yeah. Can you create concentric circle around the ship of or your model? No, not with the. Maybe you can like go deeper with Sceneform, modify some stuff, and build your own basic shape. But Sceneform only provide a sphere, cylinder, and a cube for playing with the basic stuff or ARCore. But if you want to implement some other forms, you have to do it on your own. Is it possible to store the canning of the surroundings so you don't need to do everything? Yes, there is a new API for ARCore, which I didn't mention. It's like a sort of a fast plane detection. It's really, really fast, and you can place. It's called instant place, or something like that. So you can place your 3D assets much more faster than I did. Can we determine collision between 3D objects? Yes. I think I'll add some of this in the future in my code sample. But yes, you can manage the collision between 3D objects. I don't have the code here, but you can definitely do it. Can you show the ship dancing again? It looks awesome. Yeah, I'll show a GIF of that. What feature have you built for sports app? Didn't build some sports app in AR for now, but one of the most nice thing I've seen is by a startup called Immersive, Paris-based. They are augmented like a football game with some statistics about the players, about the teams, about the how long they're running in the beach. It's quite nice to have this kind of metrics and how they can render in AR. What's the link of the GLTF validator? I'll post it later. I don't have it here. Oh, maybe AR VR. I think that's it. I don't know. Yes. It's called arvr.google.com/sceneviewer preview. So I'll share the link later. Can we manipulate parts of the 3D assets? I think so. Yeah. If you can play some animations for the GLTF, for example, I think you can access to some part of the 3D asset if it's available. You can like play part of the animation that are available. That 3D model have to conform to some particular structure, to positioning, moving, or other interaction. I develop here in iOS, and it's a not point to me. That's a good question, actually. I think, for this question, I don't know. Sorry. All right, I think that's it because I'm running out of time. And if you have any question later, so ping me on Twitter. I'll be available all day and tomorrow, or in the chat in the platform, the talk platform. So thanks a lot. Thank you very much for attending my talk. Bye bye.